Hello and welcome back to Mr. Powers Teaches Algebra. Today we're going to talk about factoring out the greatest common factor in an algebraic expression. And before we do that though, really quickly, I would like to just quickly go over what is a factor. So a factor is when we can take a number it's when we can take a number like 12. Okay? And we rewrite that as a product. Okay, so one way I could do that is 3 times 4. And afterwards, each of these happen to be factors. In this case, they are factors of 12. And so 12 has lots of factors, right? I could write 12 as 3 times 4. We could write it as 2 times 6, right? Each of these is a factor. We could even do how about negative 2 times negative 6? That would work also. Lots of ways to factor. But what's probably a little bit more useful is if there's a unique way to factor. And this is what we're usually concerned with, like unique ways to do it. So all these are different ways to factor, but I can't like say, hey, factor it completely, and then, or say something else, and everybody gets the same answer. I would say factor 12. There's a million different answers, lots of answers here, right? And notice we don't use 1. 1 is a factor of everything, and it's just silly. It's trivial, as we would like to say. So let's not worry about 1, okay? So at least as far as we're concerned here. Just because it is trivial, everything has a factor, except for things, well, I'm getting ahead of myself. Let's just move on. So 12, lots of ways to do 12. Here's the way we'd like 12, though. I like 12 is to say, let's say we start with 3 times 4. And then break it down as much as I can, not using 1, staying positive, right? I just want the positives. If there's a negative in there, then we can throw a negative on one of the factors, but or just throw it out in front. Let's get all these positives, and we get 3 times 4. 3 is a prime number, so that means I can't go any further, but 4, we could definitely go out a little bit further. 4 is the same as 2 times 2, and so I could rewrite 12 in that case as 3 times 2 times 2, and then I'd have to stop because 2's are also prime. They have no factors other than 1 and themselves. So those are prime. And we would stop there. Now, let's say we start with the smallest prime first. I got 2 2's, so I could rewrite that as 2 squared, or 2 times 2 times 3. And we'd say that's factored completely. If we're talking about integers, numbers. We got it factored down as small as possible. And so when we're talking about factoring something else, something like, say, yeah, it's a good one. X squared minus 16. If we are factoring something like this, we want to be able to rewrite it. Oh, actually, x to the 4th. Let's go x to the 4th minus 16. I'd like to keep going. So I'd like to say I could do x squared minus 4 times x squared plus 4. And then, well, this one's, I can't factor that anymore. But this one I could factor more, and I could keep going. I say x minus 2 times x plus 2. And then this one was still here, x squared plus 4. And then I'd have to stop. I'd say, okay. And that's my analog to the prime factoring for numbers. It's like these are factors as small as they can go, and I can't factor them anymore. I can't rewrite x minus 2 as a product of anything. X plus 2 I can't write as a product of anything except 1 times x plus 2. And same thing for x squared plus 4. And we have this little rule. We know that if we get down to linear factors like these and quadratic factors like these, and then we know we're factored completely, can't go anymore. Kind of like if you're stuck with prime numbers. Okay? All right. So now let's get to where I was planning to go, and that is with greatest common factors. Okay? So we're looking at common factors. Like, what do they all have in common when we're talking about stuff? So let's just take a look at some examples here and do some examples of factoring out by greatest common factor. So factor completely. Using our greatest common factor. Lots of times we'll say GCF. All right, so first one's first. Let's go ahead and do 8x to the 4th minus 4x cubed plus 10x squared. And if I'm doing this, again, what we're looking at is for these, we're going to be kind of using our property, our distributive property that we have, this kind of guy. But we're going backwards. A times B plus C is the same as AB plus AC. Right, we're kind of going from the right side back to the left. This is what we're looking for. It's to say, hey, all of these guys, all of these have something in common? So the first thing we do is look at the variable. We have 4 x's here, 3 x's here, 2 x's here. Each one of these have at least 2 x's. I know I can factor out an x squared out of each term. Like I could write this one as 8x squared times x squared. So I know x squared's a factor there. So there it is. All right. But you know what? I have to look at not just the variables, but I got to look at the numbers as well. Here I have an 8, a 4, and a 10. So I'm looking at those like what number can divide each of those, or what number is also a factor. Well, I know they're all even. So I'm just going to go with 2 for now. Pretty sure 2 will work on each of those. So 2. So 2x squared. 2x squared times what? Equals 8x to the 4th. That's going to be 2 times 4 is 8. And x squared times x squared is x to the 4th. So 2x squared times 4x squared, 8x to the 4th. There you go. Piece of cake. And then I got negative 4x cubed. So 2 times negative 2 is 4. X squared times x is x cubed. Got that one done. And then 2 times 5 is 10. So I know I'm going to have a 5 here. And x squared times 1 is x squared. So I'm not going to write anything here. That'll be it. And I have factored out using the greatest common factor. Is it factored out completely? We'd have to double check this quadratic, this trinomial. There are other strategies. We might be able to break this up more. But for now, we're going to be happy with just doing the GCF. So I'll go ahead and do one more example so that this video is not too long, but that's the gist of it. Where are we at? About 9 minutes. Okay, so let's do another example, shall we? And let's do, let's do this one. Actually, I'm going to do 2 more examples because there's one more I like a lot. So x cubed y squared plus 3x to the 4th y plus 5 x to the 5th y cubed. Okay. So I'm going to get the greatest common factor out of each of these. Bam, bam, bam. We got 3 terms. Terms are anything separated by a plus sign. You could say a minus also, but we'll just assume a minus is adding the opposite. Minus plus adding, if you have subtracting, anyway. So each of these have an x. They each have actually x cubed. I can take an x cubed out of x to the 4th and take an x cubed out of x to the 5th. So I know I'm going to have, if I could factor out an x cubed for sure. They all have y's in them as well. There's 2 y's here, 1 y here, 3 y's here. The most I could take out of all of them is 1 y. And then the numbers, a 3, you can pretend a 1's here, but it's a 3, a 5, pretend. None of those have any factors in common. 3 and 5 are both prime. So x cubed y, that's what I'm taking out. So x cubed times 1 is x cubed, so nothing need to write anything there. Y times y squared is, y times y is y squared. There we go. First term taken care of. Let's do it like this. Let's say, okay, the green here. So we only have like a 1. You pretend 1. 1 times 3 is 3. So let's just keep the 3 there. So we got 3 x cubed times x is x to the 4th, and y times 1 is y, so we're done with that one. And then let's look at this one here. The orange, we're going to have 5 x cubed times x squared is x to the 5th. Y times y squared is y cubed. And that would finish me off. That's going to be perfect. We have factored out our greatest common factor. Okay? And then one more, just because I think it's really good to see these kinds of problems. And that is 9x squared times 2x plus 7 minus 12x times 2x plus 7. These are, throw some students off, stuff like this. And it really shouldn't, but it does. So we got one term here and one term here. Okay, and we're trying to find, again, the greatest common factor. Now, one common factor you see right away is this 2x plus 7. This is a factor. We're saying 9x squared times 2x plus 7 on the left here. And then we got a negative 12x times 2x plus 7 again. So that 2x plus 7 is a common factor. So I could just write 2x plus 7. That is definitely a common factor in both of these. Now, what about the rest? Well, I got a 9 and a 12. Both of those are divisible by 3. So I know I can put a 3 out. And then an x squared and an x, both of those I could take an x out. There's one x here that I can take out, and there's 2 x's here. So the most I can take out is 1. And then what do I have left? So put parentheses here. What is going to be left? Well, 3x. We know we took out the 2x plus 7. So 3x times 3x is 9x squared. And then 3x times negative 4 is 12x. And there you go. I'm done. I think I'm done. Can I do anything else? Nah, that's it. All done. And so that's one that always kind of throws people off. And now if you think about it like this, if you did the 3x times this whole thing here, you go 3x times 3x is 9x squared times 2x plus 7. There it is. And then you did the negative 4 times this. So kind of distributing all of this into this, really. Negative 4 times 3x, negative 12x times the 2x plus 7. So that is our answer here in green. And that can throw some people off. But anyway, hopefully working it out here helps. So that'll do it for us for today. If you guys have any other questions, you know where to reach me. I hope you have a wonderful day. Until next time, have fun doing math.